Hello, and welcome to Lesson 1-3. We are talking about our friend the function family and function notation. Alright, so Lesson 1-3. Involves a couple vocab words and some ideas. I'm going to briefly talk about 1-3. We'll go over a couple examples. I will tell you that you probably need to pause the video and make sure you've printed out the student assignment 1.3. You can find that on the portal page. I would press out all those lesson assignments. They make for excellent notes and additional studying. And that way you're able to keep up with me when I talk about certain examples. Alright, so welcome back. Hopefully you've paused it and then you played it again. It's going to be hard to keep up with me if you don't have those lesson assignments printed out. But can you do it? Yes, you can. Alright. First of all is understanding some vocab, and the first one is function notation. Now, function notation is just how you write the problem. Okay? So, function notation uses f of x or g of x or q of x or p of y. It talks about the function you are dealing with and the variable you would plug in. Okay. So, can variables change? You've learned that in pre-algebra. Yes, you can have different letters that mean different things. It's basically a placeholder for a number. So the function notation tells me that this is my math problem and this is what I'm putting in for this variable. Okay. We use f of x. You'll find you use f of x most of your academic career. F of x is the same as y or similar to. Okay. The function of x or y. This is also your output, as well as it is also your correct. So you have your y, your f of x, your output, and it is also yes, your dependent variable. The independent is your x. Alright, so function notation, how you write a problem. Alright, here we go. The 5 function families. What can you tell from a function written problem? Well, you can tell the following 3 things. 1, is it a straight? Is it made up of lines? Or is it a curve? Okay, so that's the first thing. Is it lines or is it a curve? Sometimes it's 1 line, sometimes it can be 2 lines. Okay. Or is it a curve? Second, what direction is it going? And that's the easy one. Is it increasing? Hopefully you know that's positive. And if it's decreasing, it would be negative, correct. And then do you have a maximum or minimum? Now, to have a maximum or minimum, you have to have had changed directions. So, for example, if I increased, then decreased, if I increased, then decreased, this would be called a maximum. If I decreased, then increased, this would be called a minimum. As you can see, I would have to change directions in order to have a maximum or minimum. All right, so here we go. Determining what the function is based on what you see in the problem. Where is the x? So here we go, function notation. F of x equals 3x plus 4. The x is in the problem. This is what we call linear. Okay. Your basic linear equation. Most of you have seen these. A linear equation can look like this. Okay. These are all examples of what a linear equation can be. It doesn't have to have the end. That's our whole mx plus b. You know, this is the slope. Okay. Now, so where is the x, and then what is the sign next to it? So in both of these, the sign would be positive, so my line would be going up. Remember, we read a graph, we read math left to right. Okay, the next one is, well, let's say we have something that has these lines. Now, this is a throwback because you should know what these are called. Those are called what? And if you don't, that'll be a vocab that you have to study. These are called absolute value signs. Okay, that's absolute value. And absolute value makes things positive. All right, so absolute value, I go, where's the x? Well, it looks similar to the linear. The difference is it's in parentheses. So this is an absolute value family, okay? Which means all of these, and I like the fact that we use value, have a V when you graph them. So they'll either go this way or they'll go this way. Okay, absolute value. It will face up if it's positive, it'll face down if it's negative. But where would the negative sign be? Well, for one that's going down, the negative sign will be right next to the absolute value. So it might look like you're supposed to be subtracting the absolute value of 3x, but understand that that sign makes that picture. Whereas the first sign makes this picture. In both these problems, you'd have 1/2. The first one looks like this. The second one kind of looks like this. And you'll understand later on how this first number, slope, adjusts the steepness of the line. The bigger the number, the steeper it is. The lower the number from 1 or fraction makes it flatter. Okay? But both of these are increasing. If you had a negative sign in front of this, then this second one would then be decreasing. It would look like that. All right? So you have linear, absolute value. Next one is an easy one to pick up. Okay? When I look at it, I go, where is that x? Well, in this one, where is the x located? Who remembers what this spot is called? Correct. It's called an exponent. Guess what this form is called? It's called exponential. Okay, exponential form. And again, the sign in front of it tells me whether it is increasing or decreasing. So exponential, for the first one, that 3 to the x, would look something like this. The 5 to the negative 3x would look something like this. It's decreasing. Okay? So understanding whether it's increasing or decreasing is the sign. And then where the x is tells me what family it is. Okay, now these are all really important because it gives you an idea of what you're going to graph before you even graph it. Okay. All right, number 4 is one that you should have seen before. Now, In this problem, I'm looking at it and I go, ooh, wait a minute. I see the x. It looks a lot like it's supposed to be linear. But wait a minute. This one is raised to an exponent. Okay, so I have to look at the problem and see where the x is, and then what is happening to the x. See, the x is in the exponent here, so that's exponential. The x is inside the absolute values. It's an absolute value function. The x is all by itself. There's nothing attached to it, so that's linear. Well, this time, there's a squared attached to it. And any x with the squared, okay, anytime it's raised, this is called quadratic. Okay, and these quadratic functions are always in the shape of a parabola. Now I'll spell that for you. Parabola. All right, so there are your four of your five functions. And believe it or not, the fifth function family is called piecewise. Because it usually contains more than one piece, correct? It's called piecewise for a reason. Now, a lot of times it's linear piecewise. And linear piecewise is the one graph that kind of looked like that all the time. Okay? Which means you won't just have one function, you'll have several functions. Why? Because you're having pieces of functions and you're putting them all together. So this one is usually very easy to pick because it'll have more than one function. Okay, it'll have like 3 of them there. And when it has 3 of them, then it's telling you it has either 3 lines. It could, in theory, it could have a piece of it be quadratic, and then a piece absolute value, and then a piece linear. I mean, it could. It would be taking combinations, but each one of those problems would be in these brackets. So you'd have a quadratic problem in here, you'd have an absolute value problem in here, and then you'd have a linear problem in here. Okay. The one we deal the most with is linear piecewise. Obviously, all the equations in here would be linear. So instead of one problem and one problem, you would just have both those problems listed in here. Now it's linear piecewise. For every line, you'd have to have a linear equation. Okay, now, what controls increasing or decreasing? Right in front of the x. So obviously this one's decreasing, this one's increasing. In absolute value, it's in front of the absolute value sign. Okay, those are important things you have to remember. All right, hopefully you're writing all this down and not just copying what my pictures are. Remember, it's what I say. And then in the quadratic, it's the number in front of the x. Just like here, it would be the number in front of the x. So this is actually attached to it. So if it was negative 3x, then this goes down. This is negative 1/2. We said it went down. This is 3x squared. It goes up. If it was negative 3x squared, then it would go down. All right? So that's brief on your function families. Okay, we're going to talk about domains and ranges really quick. All right? Domains, and this is what we were talking about the other day. This is quick now. Domains are all of the x values. So I'm going to draw a generic graph, and I'm going to put a shape on it, a parabola. Okay, this is a quadratic. Okay, and I'm going to tell you that this is 1, 2, 3. This is at -4. Okay, 0, -4. That means I didn't go left or right. I just went down 4. So this would be called an absolute minimum, correct? This is an absolute minimum. Now, if I asked you, this line is a representation of all the answers. Anytime you do a graph, the picture you put on there are what all the answers are. So when I say, what is the domain, I'm asking, what are all the possible x's? Okay, so these values here. And I'm telling you that because it's a parabola, it's going to keep going, right? Just like any function would keep going. So that means all of my answers would be all real numbers. Well, why is that? Because all of the x's are going to be used. As I keep going out and out and out, I will use every x on this line. So there's an x here, x here, x here, x here, x here, and it keeps going, 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 going. It's never going to end because that's what a parabola does. So for my domain, it's all real x's, all real numbers, because it keeps going. Same thing with a line. It would be all real numbers because the line keeps going forever, and it would keep stretching across the x's. Now, let's look at the ranges. That's the one that's going to be a little goofy. And this is on the software as well. Hopefully you get that your ranges have to be all numbers greater than what value? Well, let's see. Here are my y's. Are there any y's that I'm using below -4? No, because this is my minimum. That means all the y's have to be greater than -4. Why? Because I'm not going to put a dot any lower than -4. So if I were to, like, imaginary put dots all the way around there, I would never put a dot lower than -4 on the y. But I would put a dot anywhere on the x's as I'm going up my picture. Okay, so -10 would be an x. It'd be way up off my paper, but -10 would be an x that I could use, and it would be a positive y value. But I'll never have anything lower than -4. So your domains and ranges are based on the picture. So if you can find the maximum or minimum or a point, you're able to tell me, oh, okay, well, all of the domains are being used, all the numbers, but for the ranges, I can only use -4 or higher. So that means it would be greater than or equal to. All right, now this is brief. You're going to be doing a bunch of this in the software. So you got to be paying attention to that. That's more in the software than anything else. All right, thank you very much for watching 1-3. Hopefully you wrote way more than what I put on the paper. And we'll see you. We'll be using these notes on Wednesday. Remember, you have a test a week from this Tuesday. And we have an Illuminate session. A study review on that Monday night. All right, we'll see you.